We're here today with Colin Heiler, CEO of Optimus Technologies. Colin, can you tell us a little bit about Optimus Technology and some of the alternative fuel and other businesses you're involved in?
Yeah, so Optimus Technologies designs and builds fuel systems for diesel engines to operate on a variety of different biofuels, primarily biodiesel and straight vegetable oils. So we build a retrofit system. It bolts onto existing diesel engines. Our primary market is medium and heavy duty trucks because there's a cost savings with utilizing the fuel that's driven primarily by the amount of fuel that's consumed. So our target consumer, our target customer is someone that's using a significant amount of fuel on an annual basis.
So some of the projects that you're involved in right now, I know that you're working, your technology basically allows vehicles to run either 100% diesel or 100% biodiesel or other biofuel products.
Right, yeah, so our system, it's an auxiliary system. It goes on to the vehicle, enabling it to be a biofuel vehicle. So if there's fuel not available or any errors or issues with the system, it'll automatically default back to traditional diesel. The system itself is entirely automated. So from a driver perspective, all they need to do is get in, turn the key, and continue on their daily normal operation. Once the system parameters have been met, the computer controller will automatically switch to the alternative fuel. It'll continue to operate on that alternative fuel through the normal operation. And then once the key is removed from the engine, the system will run a quick purge cycle where it switches back to the diesel fuel, flushes the engine with traditional diesel fuel, and then turns the engine off automatically.
So I know also you're working with the Westmoreland operating engineers on some things on other than motor vehicles.
Correct, yeah. So our primary projects are localized distribution and regional fleets. But we also have a large project with the Western Pennsylvania operating engineers, their training program, which is out in Westmoreland County, New Alexandria. And there we've completed 22 system retrofits on a variety of different pieces of heavy equipment. So things from cranes to bulldozers to scrapers, and that, again, all large heavy diesel equipment utilizing both biodiesel and vegetable oil in that project.
So who are some of the local organizations that are now testing your technology?
We have projects set up with the City of Pittsburgh Public Works. So we've installed a fueling station at their site and retrofit five of their public works vehicles for test. We've got a project for the past couple of years that we've been working on with Giant Eagle. We're in the process right now of retrofitting an additional 10 vehicles for Giant Eagle, and we have a number of other partners like Global Links, the Food Bank, and other regional partners that we've been working with to deploy the technology.
Colin, this is all the components that kind of make up your system to be put on vehicles. Can you kind of explain what they are? What they do?
Yeah. So we can start back here. This is the auxiliary fuel tank that goes on board. So we typically replicate the OEM tank. So this is the same size, shape, capacity as the OEM tank. It mounts onto the vehicle, and the tank itself is heated. So with biodiesel or vegetable oil or animal fats, one of the primary challenges for utilizing it in a traditional diesel engine is the viscosity and the cold weather properties. So this unit here has an embedded heat exchanger, and as the engine is started, again we start on traditional diesel, as the engine started there's hot coolant that circulates through the system and that's heating the fuel. It heats the tank to ensure that the fuel is liquid enough to flow through the remainder of the system. So as fuel leaves the tank, it travels to our manifold unit. So this is our vector manifold. This is the core of the mechanical system. Embedded within the unit, there are a variety of different sensors, including filter pressure, system pressure, the coolant input and output temperatures. So we're monitoring the flow rate of the coolant and the temperature, so that way we know we can identify the target viscosity of the fuel. We're also measuring at a variety of points the temperature of the actual fuel. So this unit acts as a heat exchanger. There's an embedded filter, we've got a pre-filter, and then we have a pump and air separation unit. This is some patented technology that we've licensed exclusively for use with biofuels, and this system actually helps to reduce, further reduce the emissions. The tailpipe emissions from the fuel, also improves the fuel economy and the performance. And this unit supplies positive pressure fuel to the engine. So the engine, we've got over here, this would be the selector valve. So we have a diesel fuel input, we've got our biofuel input, and then this bottom port here is what actually supplies fuel to the engine. So the two fuels are supplied at this valve, and it's electronically controlled to determine and select which fuel is being utilized. This port here recirculates fuel, so when the system's first started up, we're operating on traditional diesel. We run a recirculation cycle, which is what this valve enables us to do. So we're actually recirculating fuel through our own system before supplying it to the engine. And that enables us to ensure that the temperature point and the viscosity, the system pressure, all the operating parameters are met before we actually switch over to the auxiliary system. And during operation, if there are any challenges or any issues, the system will automatically default back to the traditional diesel side. This back here, this is a vehicle-specific mounting bracket. So this is actually what enables us to easily integrate all of these components, basically bolts right onto the frame rail. So it's three quick bolts. All of this comes together, makes the installation very, very convenient, and significantly reduces the overall amount of time. So because we're integrating into the OEM system, we're running all new fuel lines and coolant lines for our portion of the system. So that's what these are. When we build a kit, we build an engine-specific kit, and it comes with all the hoses, all the fittings, everything that's required to retrofit the device quickly and efficiently. And in the back here, we have our wiring harness. This panel integrates to one of the existing configuration boxes that's on the vehicle. So we're mounting this. All the connectors are weatherproof, quick connect fittings. So the wiring harness, the installation, everything comes prefabbed, and it's just a matter of a few hours to run those wires and mount that panel connector. Down here we have the brains of the system. So this is actually the processor and the ECU that controls and monitors the operation of the system. So we have two nodes to the electronics. One of them is communicating with the engine ECU, the other communicates with our system, and they communicate with one another to ensure that all of the properties and all the parameters and the software state are synced. So again, we're starting up on traditional diesel. We're communicating with the engine ECU, so we're getting information off of the CAN bus from the engine, such as vehicle speed, fuel economy, performance, things like that. And as we further refine the software, we'll have the ability to actually start adapting and modifying some of those engine parameters. The system does data logging and has a telemetric capability. So we're logging operational status, information on the engine, the driver, a variety of different parameters that are useful and beneficial to the fleets and the technicians that are servicing the equipment. So these systems will log up to 8 gigs of data, which is essentially a few years worth of data. And then there's a wireless communication device embedded within the system. And whenever the truck or piece of equipment is within a mile of the home base, it'll automatically communicate those system parameters and the logged data back to the Optimus server. The last component here looks like a GPS. This is our user interface. So this gets mounted on the dash or somewhere accessible to the driver. This unit provides information and feedback on the system, its operation, and ultimately is where the fuel level of the auxiliary tank is displayed. So this, from a driver's perspective, the only thing that this is really providing them is information on the system, whether or not it's engaged or disengaged, and the fuel level of the biofuel tank. And because it's an auxiliary system, sometimes the driver might, especially early on, lapse or forget that they've got an auxiliary tank to refuel. Once the system recognizes that there's less than 10% of the fuel left in the biofuel tank, it'll actually automatically switch back over to traditional diesel. That way you're not running the vehicle out of fuel. But this entire the entire software and the parameters and the control system completely automated. So there's nothing, no change in experience or operation from a driver's perspective. They can just get in and drive, whether or not a truck has our system retrofit or is traditional is a traditional diesel vehicle.